All right. So in terms of content, the lecture exam is going to cover intro, chem, cells, tissues, and the integumentary system. And the lab is going to cover intro. So that's all those terms, body regions, planes. And so everything in the lab manual for the intro is fair game. You know, it's just like your quiz. Then the cells and tissues. Okay. Now, in both cells and tissues, you had to do two activities. You had to do activity 1 that was based on your textbook, and activity 2 where it's based on actual histology images. And it's going to be on the histology images that will be on the exam. Okay. So for the lab exam, it'll have the intro, all of those terms, all of those planes and body regions that you have to identify. Then for cells and tissues, of the images, it's going to be the images that you see in the PDF in terms of the actual histological slides. Okay. Any questions so far in terms of content?
So for chapter 2 of the cells, we just have to see the images and be able to identify the mitochondria or all the organelles, basically.
Yes. Yep.
Okay.
And since that was one of the key things that you all struggled on, we'll talk about how to do that. Okay. Yep.
Thank you.
Yeah. And then for the lecture component, a lot of students ask me what to focus on. Do you focus on the lecture? Do you focus on the textbook? I will tell you that 100% of those questions come from the lecture video. Okay. So the textbook is great to use because the textbook has additional information that can support your learning. Because sometimes you need to know like all the details before you understand. But the questions will come from 100%, will be on the lecture video / script. Okay, so if I were a student, I would focus on this content first before I go into the textbook readings. And if you don't have time, I would actually just focus on this. Because I know we're all, you all work and have other things, commitments in your life. So just so you know that the exams are based 100% on the lecture, video, and script. Okay. The textbook, really supportive of the materials because it's all the lecture materials come from the textbook anyways, but you'll notice that the textbook has a lot more because that textbook is meant to be for a year-long anatomy physiology, and your program only requires 1 term. So we have to kind of pick, the general information for that 1 term versus what we would have taught in a whole year, so 2 terms, and that's what is reflected in the textbook. Okay, so that's why, because this is a 1-term course, I would stick to the materials in the lecture video script, which does come from the textbook. But it's only like 50% of the intro stuff. Questions? All right. So time frame, you have 1 minute per question except for the lab exam. So the lab exam has 30 questions and it's just like your quiz. It's all write in. And it's identification and also definition, since you have the first chapter. So definitions, identification, and it's all write in. There is no word bank and spelling count. So just think of like your quiz. So just like your quizzes, but longer, because it's going to cover those 3 components, the intro terms, the cells, and the tissues. Okay. The lecture exam is 1 question per minute. So I'm sorry. So for the lab exam, you will have 45 minutes because you have to type in the content. So we're cognizant of that. So you have 45 minutes to do that. The lecture exam is, you'll have 50 minutes. So it does come to about 1 question per minute. And I know it makes a lot of you nervous, and me too as a student, whenever I'm timed, I'm nervous, even though I never use the full time. And that is a fact. I will tell you that when I look at the time that's spent, in in each class on a particular exam, it's usually around 30 minutes. So usually students finish before they use the full 50 minutes. And actually, I end up having to tell students to slow down, read the question out loud, and then process the question before answering it. Because oftentimes it's that anxiety of taking a test that makes you feel like you're running out of time, even though you only use like half of the time. Okay, so intentionally slow yourself down. And whenever you're taking anything online, it helps to read the questions out loud. Read the question out loud or read the question twice. Come up with the answer before you look at the answer options, because that helps to build confidence as well. Versus if you read the question, go straight to the answer, and you're like, oh, I'm down to this 50-50, but I can't decide. And then you end up deciding the wrong one because you like out convinced yourself that what you know wasn't correct. Make sense? So there's strategies to kind of take the test, particularly if it's online, that, helps you do better than, with and fight anxiety. Okay. All right. So the lecture exam has 50 questions. 40 of them are multiple choice and 10 of them are short answers where you kind of type in the answer. Okay. And like one of your classmates has said, I try to not to be tricky, so the first set of questions, about 7 to 8 questions, are on intro. The next 7 to 8 are on chem. So I put the questions together instead of mixing them all up. And then you're like, oh, is this from this chapter or is this from this chapter? I try to keep them within their chapters because taking a test is already stressful enough. You don't need that additional stress. Okay. So they tend to be clumped together. 7 to 8 on intake. And then the last 10 questions that are short answers, 2 from each one, 2 to 3 from each one. Okay. So, any questions on the time frame or the structure of the lecture exam and lab exam? Okay. For both, one question appears at a time. I strongly recommend that you do one question at a time and then go to the next one and then go to the next one and so on, and don't jump back and forth. And the reason for that is because if you jump back and forth, having, because you have to enter into the computer, right? And then it has to go to the next page back and forth like that. And sometimes that can cause it to kick you out. It doesn't happen often, but it has happened where students, bounce back and forth so much that when it reloads, it just gets confused. So I think my strategy, if I were a student, I would do, use the time that I need to answer completely that one question and then move on to the next one and then move on to the next one. Plus, if it kicks you out, what I do is that I have to go back in and check to see which questions you've already seen. If you've seen the question, unfortunately, I can't let you redo that question. So if you've seen all your questions, even though you didn't answer them and you get kicked out, unfortunately, because you've seen the exam, I can't do anything about it. But if you stick to one question at a time, and let's say you're only on question 20 and you get kicked out, then I can at least open from 21 onward for you to take. Okay. So there's just, it's just a little bit better to do one question at a time, spend your time on it, and then go to the next one, then rather than going back and forth all the time. Okay. There was a great question at the beginning, and that is, can you have a piece of paper? Absolutely. Okay. So you can have a blank piece of paper. Now, all exams will require the Respondus Lockdown browser. So hopefully you've been using that. In addition to that, it will require that you do a webcam and an environmental scan. That environmental scan is extremely important. Okay, that environmental scan is required and is extremely important because if Respondus Lockdown does flag you, like for example, if it notices that your eye shifts too often to one side, as if you were looking at something that you shouldn't be, then I can look at the environmental scan, which shows me your whole surroundings, your right and left. I'm particularly interested in where you're taking the exam. Okay, so you're at the right side of your table, the left side of your table, kind of, and sometimes students have a mirror in the back to kind of show that, you know, that there's no suspicion. So the environmental scan protects you more than it does anything else. Because one, I don't watch it. I don't watch your environmental scan or your videos, you know, the recordings of you taking the exam, unless respondus lockdown flags you and makes me watch it. Okay, so, you know, don't be nervous about that. I really try it to be as least invasive as possible. I only do it when I absolutely have to, and that environmental scan is what will protect you. Even though it says that, you know, you may be potentially doing something that's academically dishonest, I'm like, no, I saw his environmental scan, and there was nothing around them. They had a mirror in the back, so I know they didn't have a cell phone underneath the table and like we're typing it in. One year I had a student take pictures of the exam. So, you know, that's why you have the environmental scan, you know, it's to protect you, to make sure that you know, you didn't do anything wrong, essentially. Okay. So questions about the logistics. Okay. So troubleshooting, try to take the practice quiz before you take the exam. It's just to make sure that respondus lockdown and the webcam is working properly. It's not for any points. It's just to make sure that everything's working correctly, as well as your webcam. If you do have technical difficulties, and it does happen, okay, make sure you don't wait until the last minute to take the exam. Just stay calm and text me. You have my cell phone number in the syllabus, okay? Recommendations, how to prepare for this. And that's why I intentionally meet with students at the beginning of the study week, is because you should do what's called a 5-day study plan. And one of your classmates did amazing 5-day study plan, and I asked her if I could share, and she said yes. So I'm going to share it. Look at this amazing 5-day study plan. Okay, so which she made into a 6, which is awesome, but do a minimum of 5. So you can see she did a checklist, you know, of what is essential and needs to be done. So on day 1, she's going to cover chapter 1, module 1, intro to A&P, watch the lecture video, capture notes on the study guide, review the textbook and capture gaps, use the worksheets, test herself, and then review supplemental resources. And she also attached important documents, you know, what she needs. And you'll notice that down here, she also puts the supplemental sources here. So, because sometimes I completely understand that if there's too much resources, it can get a little bit overwhelming. So if you put it like this, it looks so doable. And it's like a checklist that you can just like be so happy that you've done it and checked it off. You know, for each check off, you can get like a candy bar or something, you know, reward yourself. Make it into like a game, you know? So highly recommend a study plan like this. Look how amazing this is. And it's so easier than to kind of have to sort through all the paperwork, all the emails, all the announcements, just have it all in one area. Okay. I'm sure maybe if you ask her, she'll share this with you. Okay. Okay. Studying, make sure, so doing well in a science course that's heavy content like this one, and yes, I do absolutely know it's a lot of content, involves 3 main things. 1, studying. 2, checking in whether you understand the content or not. And then taking test-taking strategies, which there's a video that walks you through kind of like testing strategies for when you're taking the quizzes and exams in this class. Okay. So for example, when you're doing the assessing and reviewing, you can print out another worksheet. And when you're doing the worksheet, you can do it like this. This is my recommendation for students. So take out the worksheet for each chapter, do it once without any notes. That's going to let you know what you currently know. What have you stored and have been able to organize in your memory? Okay. Then take out your notes. And in a different color, . fill in whatever is missing. Okay, so you're doing it once without notes and once with notes. That's going to let you see, okay, this is what I already have stored in my memory. This is what I still need to work on. And that's what you would work on. Make flashcards, have people quiz you, do anything that's active. Okay, avoid doing all reading, because studies show, and there's been lots of study on this, that if you study passively by just reading your notes, you're only going to remember like 30 to 40%. But if you study more actively, like you're interacting with your study material, like doing the worksheets, doing flashcards, quizzing yourself, using Quizlet, then it transitions that memory from that 30 to 40% to more closer to like 60 to 70%. And then if you do cognitive maps, that like goes up, shoots it up to like 80 to 90% your recall ability and longevity. Okay, because when you do cognitive maps, that's training your brain to store the information in. So, for example, there's a whole book that you're reading, right? You'll notice that the book is first divided to chapters. Okay, and then those chapters are divided into headings, and the headings are divided further. Okay, so that's how the books help you to remember what's in the book. It categorizes it. So all of this information in anatomy and physiology, you have to find a way to help your brain categorize that information. And that is what cognitive maps do. So a lot of you talked about, trying to remember all that, or organic compounds in chemistry. There's like so many long lists. Do cognitive maps, because not only can you visualize the map and go, okay, under carbohydrates, I saw monosaccharides, disaccharides, and polysaccharides. And under monosaccharides, I saw glucose, so on. And then this was in this. So you can actually visualize what you're seeing, as well as categorize and compartmentalize the materials. Okay? All right, I'm going to check the chat. Someone wrote in the chat. Making my own quizzes. Yes. Ariel, you just, I love your comment. Making my own quizzes on my problem areas, Quizlets, has been so helpful for me. Yes. And that's why one of your assignments for this week was to make sample test questions. I know a lot of students don't find them useful, but if you're doing them right and you're doing them often, they actually are very helpful. Okay. So write sample quiz questions, because by now you've seen all of my quizzes, so you've seen what the questions look like. And yes, the questions are going to be similar to the quiz questions. Are they the same? No. Are they similar? Yes. Okay. Study complete chapters. Oh, sorry. Study the oldest materials or the hardest materials first. I usually go with studying the oldest materials first, because that's what I'm less likely to remember, because I have memory problems. For some of you, it might be studying the hardest materials first, because the hardest materials take more time for you to process. Okay. And then study complete chapters. Don't jump around. Okay. All right. Questions, comments, suggestions? Okay, I'll move on. All right. So and again, if you have any questions, this is your session, okay? So if you have any questions, just stop me and ask. So the first thing that you should know is the scientific method. Make sure you know the terms, the definitions, and then know what's anatomy, what's physiology. And sometimes the questions could be pure regurgitation. So for example, can someone define anatomy for me?
The study of structure.
Yes. Study of structure. So the test question could be, the study of structure is which term? Anatomy, physiology, so on. And I'll put some other terms in there, right? Or it could be an application question. So I can get at the same thing, but in a different way. So here's an example test question. You are studying the chambers of a heart. Which term fits this case? And then you would say anatomy, because the chambers of the heart are structures. Okay, so those are the ways I can change a question on the same topic. Okay, make sure you know the levels of hierarchy. So the smallest is atoms, to molecules, to organelle, to cell, to tissues, to organs, organ system, and then finally an organism. It could be pure regurgitation. So for example, list the following in the order of least to highest. Or the question could be list the order from highest to least. So the point of this is to make sure you read the question. Because sometimes students just jump to, a conclusion of, oh, the question must be asking this. But no, it could be worded differently, and you have to be able to catch that, okay? So it could be per regurgitation, where I ask you to put these in the correct order. Or it could be, okay, I have hydrogen, I have water, I have the heart, I have the integumentary, and I'll ask you to put those in the correct order from highest to lowest. And what would that be? What should come first if it's the highest to lowest? What would be first?
The integumentary system.
Yes, ma'am. Followed by?
The heart.
Keep going.
Oh, okay. Then water and then hydrogen.
That's right. Organ system, organ, molecule, atom. So that's another way in which I can ask the test question. Okay? So make sure you know it backwards to frontwards. Know it so well that you can do something like that. Okay? Now you absolutely know there's no way of escaping this on the exam. Homeostasis. Homeostasis is an important concept that if you were to leave this class with one thing, with absolutely just one thing, it would be homeostasis. We talk about homeostasis through every single chapter, okay? Because that's why you're here. You're in a health profession, and that's what determines health, is your ability to maintain stable internal environments. So you need to understand how that works, the mechanisms behind that, and what happens when you don't maintain homeostasis, okay? And that's what we talk about in negative feedback, positive feedback, and what happens when you deviate from that, okay? So make sure you know what homeostasis is. Make sure you know what dynamic equilibrium is, what a set point is, know the examples. So for example, I can say childbirth, fever, blood clotting, and body temperature. Which one of these is negative feedback? And what would you say?
Body temperature.
That's right. Okay, so you need to be able to distinguish what's negative feedback, what's positive feedback, and so on. And there's also a lot of terms in introductory. Okay.
That's a question
right.
on this.
Yeah.
So in the homeostasis, you have the negative feedback versus positive feedback. So homeostasis and feedback are their own thing, and positive feedback is a separate thing. It's not part of homeostasis, correct?
Yes.
Okay, so I
That's right.
understand it right. Okay, thank you.
Yep. Yeah. Negative feedback is what supports homeostasis. Positive feedback is a function of the body. It is a regular function of the body, but it does not support homeostasis. It actually moves away from stable internal environments. But sometimes you have to do that, right? Like if you have a fever or if you have an infection, you can't keep body temperature, because over time, our bodies have come to realize that when we increase body temperature, it prevents bacteria from growing. And that's why we undergo fever. So fever is a process of the body. It does drive you away from homeostasis, but your body has to go, okay, between these two dangerous situations, what's more dangerous? And it's going to say, okay, having an infection is going to be more dangerous than having a fever. Even though, can you die from a fever? Absolutely. Okay. Can you die from childbirth? Absolutely. Can you die from blood clotting? Yes. But these options are better than the other option. So positive feedback is a processes of the body, a needed process of the body, but it does cause you to deviate away from homeostasis. Okay? All right.
Thank you.
Yeah, great question. Chemistry. I struggled with chemistry myself. Chemistry is not my friend. So I try to make it as basic as possible. So I do a lot of supplemental video. I did one supplemental video on that. I highly recommend you watching it if you have time. Okay. So that's where I kind of slowly go through how to do how molecules are formed. Like, for example, ionic versus covalent versus hydrogen. Know the terms, what's an atom versus an ion versus a molecule, which is a solute, solution, so on. Because you know that's going to be on the test. Okay. And just a simple thing like this. The types of ions, there are two types of ions. There's cation and anion. And I go like this. Okay, cation has a T, which is a positive sign. So I go, okay, cation has a T with a positive sign. That means that it's a positively charged ion. And then that makes anions negatively charged. So I find little things like this that is simple. It doesn't take too much of my space in my brain to help me remember. Okay, so do that. Spend enough time with this material that you can go, oh, okay, here's a way to remember it. Okay. Molecules, make sure you understand the difference between a stable state of a molecule versus neutral. Which one do atoms prefer to be, stable or neutral?
Stable.
Yes, thank you. They prefer to be stable. Absolutely. So because they prefer to be stable over neutral, they're going to transition their electrons. They're going to move electrons around. Either they're going to give the electrons or they're going to take electrons. But either way, whatever they're going to do, they're going to do it so they become stable. Sometimes it's about giving or taking. Sometimes it's about sharing electrons. Whatever it takes to become a stable element. Okay, because they're originally neutral. Okay, so they're originally neutral, but they prefer to be stable. And because of that, they either give their electrons or they share electrons. And that's what results in two elements or two atoms coming together and bonding and resulting in a molecule. Okay. With the pH scale, make sure you know what a pH scale is. Just, if you're a history fan. So P is the math term for logarithms. Logarithms. And logarithms are inverse calculations. So in other words, the greater the value, the smaller the number. Okay. And it's a measurement of H, which stands for hydrogen. So it's a measurement of hydrogen, levels of hydrogen. The more hydrogen ions there are, the more acidic it is. And the more acidic it is, the lower on the pH scale it is. So pH scale goes from 0 to 14, 7 being neutral. If it's lower than 7, because remember, the lower the number, the greater the hydrogen ions. So that makes it, when it goes this way, it is acidic. Where if it goes this way, it is basic. Okay. Organic compounds, this one, I highly recommend doing a cognitive map. Because remember, it helps your brain to kind of organize all of those terms and it helps you to visualize it on the test. I had you do one, but do another one. Keep doing them until you can like do them without using any notes. So here I have the organic compounds, I have the function here, and then I categorize it by types. So monosaccharides, meaning there's only one mono, meaning one, there's one molecule. So that's glucose, fructose, galactose. Some students make mnemonics out of these, okay? For me, I found it just simpler just to remember glu, fru, and gal. And anything ends in ose, I know it's a carbohydrate. Okay. And then disaccharides, there are two molecules of them. So in other words, sucrose is a combination of a glucose and a fructose, and that's what makes sucrose. And that's table sugar. Okay. Lactose is a combination of a glucose and a galactose. The term lactate means milk, right? So that means it's a sugar, it's milk sugar. Maltose, if anyone have ever had a malt, alcoholic malt drink, that's where it comes from. Okay. It's a combination of a glucose and a glucose. Poly meaning many, so it's a long chain. So there's starches, cellulose, and glycogen. Starch is unique in that it is ingestible. You can eat it, and not only can you eat it, but you can digest it. So because you can digest it and break down that long chain into eventually a monosaccharide, it's a great source of energy. It's a great source of energy that's made by plants. Okay. Cellulose is, you can eat it, but you cannot digest it because this is plant cell wall material. And because of that, it makes great roughage. So you eat it and it goes through your digestive system. And as it goes through, because you can't break it down, it helps to clean your colon. Okay. So in this case, this sugar is a cell structure for plants. Glycogen, we don't ingest it. We make it by connecting chains of glucose together. Okay. So you would do that for the others. So there's proteins, lipids, and nucleic acids. Okay. And you did that in the first assignment, the assignment 1, right? But you did it in a little bit different way. So see if you can do it again using this chart. I will provide this PowerPoint to everybody. So use it. So that was on the organic compound. Does that help? I know that a few of you had talked about that.
Yes, thank you. I think I need to make this chart. It
Do
helps
it-
organize it a lot better.
Yes. Yep. And try to do without notes first, and then do it with notes, because then that will help you see what you know from what you don't know. Okay.
Yeah, thank you.
Yeah. Cells, for the sake of time, I'm gonna skip this. I'll just kind of read through it really quickly, but I'm not gonna go into much detail. Okay. So for cells, make sure you know the structure and function. A lot of you made wonderful videos. Watch your peer videos, because I'm not going to get insulted if you prefer their lecture over mine. Because here's the thing, I can give you the content, but they can give it to you maybe in a different way that helps you click or understand better. So the more you expose yourself to the various different lectures, it helps. Maybe one you'll click with more than others, but a note of caution, you have to make sure that if there is something wrong in there, if there's a misinformation, then you want to make sure you catch that as well. Okay. There's a comment in the chat. Let me check on that. Stable. Thank you for saying scale. That was I know. Log, yeah, pH, yep. Okay. Plasma membrane, make sure you know the structure of the plasma membrane. Sometimes for me when I'm studying this, and that's why I say I'm old school. So I prefer to write out my notes. So I'll under plasma membrane, I'll just draw it. And I'll be like, okay, so what are these? Why are they situated the way they are? And that will help me to understand that these are phospholipids, these are the fatty acid tails, this is the phosphate head, and they're situated like this because the fatty acid tails are what? Hydro what?
Hydrophobic.
Yes, meaning they have a fear or dislike of water, because guess what's on the outside of a cell? Water. Guess what's on the inside of a cell? Water. Okay, so we truly are like 96 or 98% water. There's water everywhere in us. Okay. All right. So by drawing it out, it helps you kind of see, oh, okay, that's why those fatty acid tails face each other, where the phosphate head faces outside, because the phosphate heads are hydrophilic. Yes, because they interact fine with water. Okay. And also because of the fatty acid tails, they don't like water. Only things that are certain things can move through the membrane. Other things have to move through these proteins, these channels or these gates. Okay. So then you should also then think, oh, what's the difference between a channel, a gate, a carrier? And that will walk you into the different types of proteins that you find in a plasma membrane. Okay. Then that will also lead you to, okay, so then how do things move through? Then you have passive meaning what? Always two things. What are the two true things about all types of passive mechanisms?
They don't use energy.
Yep.
ATP.
What else?
Usually goes from lower to higher.
Oh, so close.
Ah,
High to low. Okay. So let me explain why that is. Things in nature always go from high to low. So here's the thing. Okay. So here's a membrane that it can cross, right? So there's only 3 here, and there's like a gazillion here. Okay. So here's the thing, right? When you have one item moving and they bounce, the likelihood of them bumping into each other is greater when it's in the area of higher. So then they're going to disperse themselves naturally. Where when it's in low, they already have a lot of room. So the chance of them bumping each other is a lot lower. So things will always go from high to low. So for example, if you've ever made Kool-Aid, I don't know whoever makes this anymore, but I used to make Kool-Aid. I would pour the granules of Kool-Aid, and then without even stirring, I will notice that it diffuses because things always go from where it's high to where it's low. Okay. So use things like that to kind of help you remember, like connect it to everyday things that you do or use in your life. Okay. But yeah, that does mean it takes time. Yep. And that's why we give you this material a lot, way in advance so that it takes your brain time to process it and go, oh, that's kind of like this. I can use that to help me remember. Okay. All right. And then the organelles, you all did a great job. The only thing I will say though is that in a lot of your cell videos, a lot of you did not fully mention all the functions of the smooth endoplasmic reticulum. There are 3. And a lot of you did not talk about the function of the rough endoplasmic reticulum. Okay, so let's just clear that right now. So what's the 3 functions of smooth endoplasmic reticulum? 1.
It helps to detoxify the cytoplasm.
Yes, it helps to remove the alcohol and the drugs. Yep, and that's why you'll find a lot of smooth ER in your liver. Okay, 2.
isn't it where the peroxisomes are made?
Not necessarily, no. But the peroxisomes relate in that they also detoxify. But they detoxify more like radicals. So they both clean up. What's the second function?
It doesn't contain ribosomes.
Nope, smooth ER has no ribosomes. It stores minerals. It stores minerals like calcium, which is why when we get to the unit on muscle, we're going to learn about smooth ER, the role of how calcium moves around through the smooth endoplasmic reticulum in order to allow for muscle contraction. Thirdly, it produces lipids. It synthesizes lipids. Okay, so 3 functions of the smooth ER. The one that all the students mention is detoxify alcohol and drugs. That's right, but it does also store minerals like calcium. And 3, it synthesizes lipids. Where the rough endoplasmic reticulum is really cool because you'll notice that it's large and it connects from the nucleus to the cell membrane. And the reason for that is because it's a highway. It helps to transport cellular materials from where it first is made from near the nucleus and then out to the cell membrane if it needs to be exported. Okay, so the rough endoplasmic reticulum is a network of channels that allow for things to move. And it just happens, there's ribosomes there as well. So guess what? One of the things are being made. Ribosomes synthesize what?
Our DNA,
Not
the little
DNA.
structure.
You're right, the little structures. What are those little structures?
Proteins?
Proteins, that's it. So that's why you find the ribosomes attached to the rough endoplasmic reticulum, because it's a highway. So it's like, oh, here's a stop station where I'm going to make proteins and then continue to ship it off. Okay. All right. So those are the main things that I caught in those videos. So organelles, otherwise you were so creative. You probably are one of the most creative classes I've had. So I love it. I love it. Absolutely love it. Okay. Here's something that I did in class. So I teach this class in person at St. Kate's as well. So I usually just draw it out and I label, and then next to my labeling, I put function. You should see if you can do this without using notes. Okay, do it twice, once without notes and once with notes. Okay, and see what are you missing? Because it's not just about studying and putting things in your brain. It's also about organizing it in your brain and then being able to pull it out. Because I've had a common student experience where I'm like, oh, I studied it. I really studied, but I can't remember. And that's because we didn't practice pulling it out. Because you have to practice pulling the information out. And that's what doing these drawings without using notes, labeling, and then putting the definitions down do. It helps you to see what can you pull out. Okay? All right. Tissues, everybody's bane. Tissues. Okay. So tissues, make sure you know the structure and function. And there are 4 types of tissues: epithelium, connective, muscular, and nervous. We didn't really cover muscular too much. There's probably going to be like one question if you encounter it on these, because they have their own chapters. Okay, and as a matter of fact, muscle has 2 chapters and nervous has 3 chapters. And that's why we don't cover too much on it at this point. We really cover epithelium and connective mostly. All right. So the best way, and unfortunately, the reason why a lot of you are struggling on this is because it's a lot of content, not too much physiology, all memorization. So you got to come up with a way that works best for you to memorize it. Okay. I can give you a few suggestions, but again, there's not a magic bullet, right? Because each student learns differently. So you keep working at it until you get it. Just, don't give up. It takes time, but you will get it. Okay. One of the things that has helped my students in the past is to kind of, and that's why when I lecture like this. So in tissues, you have the epithelium right here. Let me do a different color. Okay. The first thing you want to do is go through the characteristics of epithelium. Okay. Now, I noticed that a few of you struggled on this one because there's the difference between functions of epithelium versus characteristics of epithelium. And you need to make sure that you're understanding which question I'm asking you on the test. Am I asking you a function of epithelium, or am I asking you a characteristic of epithelium? So for example, epithelial tissue tends to be avascular, meaning it has no blood vessel. Is that a function or is that a characteristic?
I'm sorry.
Characteristic.
Characteristic.
Yeah. So one of you answered and one of you wanted me to repeat it. So let me repeat it first. So you need to be able to know the difference between a function versus a characteristic. So my example was epithelial tissue is avascular, meaning it has no blood vessels. So the term avascular, is that a function of epithelium or is it a characteristic of epithelium?
Characteristic.
Yes. So if I say epithelial tissue lines all surfaces, internal and external surfaces. Is that a characteristic or is it a function?
Function.
Yes. Okay. So on that worksheet that I had you do, a lot of you confused those. Like, you know, where it was function, you listed characteristics. Where it was characteristics, you listed function. And the test will ask you what is a function of epithelium or what is a characteristic of epithelium. Okay. So be able to distinguish that. So what's the characteristic versus what's the function? Then how do you categorize epithelial tissue? And we're going to do it based on the number of layers and its shape. So let's do layers first. There are two types of layers. If it's just one layer, it's always going to be simple. It gets more complicated when it has two or more layers, when it's stratified. How can you tell? Because tissue isn't always going to be, okay, I'm presenting myself to you in the exact correct orientation. No, if you cut a blood vessel, it's going to be round. It's going to go look like this. Nope. There you go. If I'm cutting a, I don't know, lung tissue, it's going to be sideways. Okay. So how you can tell whether it's simple or stratified is to look for these two characteristics. Always look for the basement membrane. The basement membrane is going to be where it's darker, like this. Here's a basement membrane. 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 There's like a darker line, okay, that anchors the epithelium down. Because epithelium lines all surfaces, something's got to hold it down in place, and that's the basement membrane. Which means then, on the opposite side, right here would be the free surface. Here's a free surface. Here's a free surface. Here's the free surface. Here's the free surface. And here is the free surface. And over here, this top right here, this is the free surface. So from the basement membrane going up, let's look at this one right here. So here's one cell. There's another cell that's just squeezed in. It's tricky though, right? Because it looks like it's two squares, two cuboidal cells stacked on top of each other, but it's actually a columnar cell that is just next to each other, but it's wedged in such a way that it looks like it's stacked. So this right here is technically what? Simple or stratified?
Simple.
Yes.
Stratified.
No, it's simple. Because if I peel the cells apart, it's only one layer of cells. It looks stratified, and that's what makes this tissue this epithelium so tricky. And that's why we call it pseudo-stratified columnar epithelium. Pseudo meaning false, stratified meaning multiple layers, because it's a false multiple layer. It looks like it's multiple layer, but it's actually simple. And that's why we call it pseudo-stratified columnar epithelium. Okay, where this one right here is a tube. Let's say that this is a kidney tube. So from the basement membrane to the free surface, how many layers do you see? 1, 2, or 3?
2?
2, that's right. So in this case, you would call this simple or stratified?
Stratified.
Yes. And then you add the name of the shape. By the way, some of you on your quiz, you missed one of the names. So for epithelium, you have to have the layer name and the shape name. So in this case, it would be stratified cuboidal epithelium. Okay? How about this next one? So from the basement membrane counting up to the free surface, is there more than one or is there just one layer?
Multiple layers.
Yep,
More.
so it's stratified. And then identify the shape for me.
Cuboidal.
No,
Columnar?
no,
Squamous.
yes. Okay, so that's a great point though. That means, okay, so you're seeing it this way, right? You need to rotate it this way so that the basement membrane is on the bottom and the free surface is on the top. Then you can tell what shape it is. Because otherwise, if you look like this, then yeah, it looks like columnar, but it's not, okay? Because its true orientation is like this, where the basement membrane is on the bottom and the free surface is on the top. So if I rotate that image this way, it's thin and flat, which makes it stratified squamous epithelium. Question. Okay, all right. Then columnar epithelium have certain things that tend to be associated with it. So it tends to have these cilia, these hair-like structures associated with it. Okay, so here's pseudostratified columnar, again, columnar, which means it has these cilia associated with it. All right, okay. What else? Oh, one more exception. This one right here. Originally, it looks like this. This is your urinary bladder, by the way. So when your urinary bladder is empty, it looks like this. What is this? What's number one?
Stratified cuboidal?
Yes. And when you produce a lot of urine, it looks like this. So what does it become?
Squamous?
Stratified squamous. That's right. So this is a unique type of tissue that will change its shape back and forth depending on the condition. What do we call this type?
Would this be transitional?
Yes, it would be. Very great. Very good. It's transitional epithelium. All right. So that's the epitheliums. Okay. Then nervous, make sure you know the characteristics, the function. There's two types. There's neurons, which are the actual nerve cells, and then the nerve glial, which are the supportive cells. So this is what a neuron looks like. It has three main components. It's got the dendrites, it's got the soma, and then it's got the axon. Okay.
Quick
Then, yeah, go ahead.
So where do we find what the organs that the epithelial tissue is at?
Ah, yes. So that you actually don't necessarily need to know quite yet, but you do need to
Okay.
start making associations. Like, for example, at this point, we're saying that the pseudostratified columnar epithelium right here tend to line the upper respiratory tract. But you don't need to know it at this point until we get to the respiratory system. And that's when we actually tell you, you have to know what lines these tissue.
Okay,
So,
gotcha.
yeah.
Thank you.
Yeah. So we'll start to kind of let you know what things are what, but you don't need to know for this exam at this unit yet. You will eventually, but not at this unit. All right. So with muscles, same thing, know the characteristics, the function, know that it's based on these two terms where it's voluntary or involuntary, whether it's striated or non-striated. Because of these two terms, we've got skeletal, we've got cardiac, and we've got smooth. Okay. Connective. Everybody hates connective, and rightly so, because anything that didn't fit into the other three got thrown into connective. Okay. And that's why it has so many functions. It does everything from bottom to top because everything else got thrown into connective. Okay. But it
Can I
does
ask a
have
question?
yeah, of course, always.
What is the difference between skeletal and bone? Isn't bone make skeleton?
That is a very good question. Skeletal muscle is different from skeleton. So the skeletal muscle wraps around bone. So it's the muscle around bone. And that's why it's called skeletal.
Thank you.
Yep. Yes, ma'am. Where skeleton is the actual bone. Yep. Great question. Oh, all right. So for connective, there are very particular characteristics and functions of connective tissue. So you will know that connective tissue has, all connective tissue has variations of these three things. They're going to have some type of cell. They're going to have some type of ground substance, and they're going to have some type of fibers. Some are named or categorized the way they are based on how much of what they have or what they have of each one. For example, bone is called bone because it has osteocytes, bone cells. Okay, so that's the type of cells it has. Ground substance, it has calcium phosphate. For fibers, it's going to have collagen. Okay, so it has those three elements. Okay, it's going to have osteocytes, calcium for its cell. It's going to have calcium phosphate for its ground substance. It's going to have collagen for its fibers. That's what makes this uniquely bone. And kind of my association to help me remember, I'm just going to put a note right here. It looks like a cut of a tree. So anytime I see a cut of a tree, bone, that looks exactly like bone. Okay. Cartilage has chondrocytes. Anytime you hear the word chondro, it means cartilage. So cartilage has chondrocytes for its type of cells. Okay. Ground substance is just going to have kind of a plasma, kind of a network, a slime, a gelatinous material. Okay. And then for fibers, it's going to have, depending on which cartilage. Are we talking about hyaline cartilage? Are we talking about fibrocartilage? Are we talking about elastic cartilage? So the fibers varies. Okay. And based on what it is, it's going to tell you what specific cartilage it is. Okay. And then what helps me remember its cartilage, because it's really unique, because cartilage always have two cells that are linked together. So it looks like owl eyes. Doesn't it look like an owl? It's very unique in that it looks like it has owl eyes. So that's why when I think owl eyes, I think cartilage. Okay, so you're going to want to do this for all of them. What kind of cells do they have? What kind of ground substance do they have? What kind of fibers do they have? What is unique about them that makes them, that helps you, regardless of what image you look at, you can always go, oh, that's cartilage, that's bone, that's adipose. Okay, so for example, with adipose, they'll have adipocytes. And you'll notice that it's mostly adipocytes, not much anything else. Everything else is small amounts. So small amounts of the ground substance, which is kind of like a gelatinous material. So not anything key or important. So we just call it, because there's not a lot of it. Because look at it, it's all cells. It's a bunch of cells that are like packed within itself. Okay. And of course, that means it's not going to be any fibers either. Very small to no fibers.
With the adipose,
Mhm.
I just always think of like a marshmallow pack because they're
Yes.
closely packed together and they look like, fat marshmallows.
That's right. That's great. That works. Yeah, that's what I'm saying you need to do. You need to associate, and that's what will help you remember. It's funny, but it works. And that's why I had you do like videos, right? Because when you do the videos, a lot of you did such an amazing job with the cell video, by the way, of like how you associate with airplane, you associate with schools. It's just like, wow, you're going to do so well because you're going to remember it easily. Okay, so that's what you would do. All right, so we're running out of time, so I'm going to quickly go through this. I was really surprised because normally integumentary is the most difficult for students. That means, though, I'm a little worried that maybe you haven't covered it quite in detail yet because it is a lot of content. And actually, between integumentary and tissues, as a student, I remember struggling with integumentary more than tissues. So if you haven't had the time yet, make sure you spend a good amount of time on integumentary system. It's a lot of memorization, so use a lot of cognitive maps, okay? So do something like this. Draw it out, label it, put the function down, and, see if you can, go through what the function of skin is: protection, synthesizing vitamin D, sensation, thermal regulation, communication. Go through the epidural layers, from superficial. The test can ask you from superficial to deep, or it can go from deep to superficial. So you just have to make sure you read the question carefully, okay? Then make sure you understand the dermis versus the hypodermis. Okay? And all the accessory organs. All
Which
right.
I
Yes.
always try to remember how the hypodermis is not part of the skin because I feel like a lot of us get that confused since
Yes.
it goes from superficial to deep. It seems like it's all together and it's not.
It's not. That's right. That's right. And that's why the worksheet, the very first question the worksheet asks, what is cutaneous versus subcutaneous? So these two are cutaneous, where this last one is subcutaneous. Oh, I found a good way to remember that is if you ever have or have given injections, sometimes you're said to give muscular injections, which is below here. Some of times you're asked to give cutaneous injections, which is between here. Sometimes you're asked to give subcutaneous injections, which is right here. So think of like injections, how thick the needle has to be. Okay. All right. Questions, how to prepare per lab, do the PDF, listen to the video. Use the PDF as a quiz. So I mentioned this at the very beginning, right? So on there, don't actually write the answer on your PDF. Write down like 1, 2, 3, and then that way make yourself. So that's the PDF. And then you just get a blank piece of paper. And then you'll write down number 1 is this, number 2 is this. Because by doing this, not only does it help you with identification, but also helps you with spelling. Okay. For lecture, focus on the PowerPoints, the videos, the scripts, the worksheets.